This video explores the remarkable life of a theoretical mathematician whose unconventional approach changed our understanding of the atom, earned him a Nobel Prize, and inspired generations of scientists. While J.J. Thomson was known for his poor hand-eye coordination, making him a rather clumsy experimenter, he possessed a brilliant mind capable of visualizing the invisible forces governing our world. Thomson's path was not straightforward. After his father's death forced him to leave engineering behind, he excelled in mathematics at Cambridge before rising to become the Cavendish Professor of Experimental Physics at just 28. Succeeding legendary figures like James Clerk Maxwell and Lord Rayleigh, Thomson brought a unique mathematical precision to the laboratory, identifying anomalies that others had simply overlooked. At the time, scientists believed the atom was indivisible. However, an international race was underway to understand mysterious cathode rays. Were they waves in the ether or actual physical particles? By applying electric and magnetic fields to these cathode rays within a vacuum tube, Thomson proved they could be deflected. This provided conclusive evidence that they were composed of negatively charged physical matter. Thomson calculated that these particles were nearly 2,000 times smaller than a hydrogen atom. He called them corpuscles, but we know them today as the electron, the first subatomic particle ever discovered. In 1904, he proposed the plum pudding model, suggesting electrons were suspended in a sphere of positive charge. While later corrected, it was a vital first step in mapping the subatomic world. Thomson's work continued into the 1910s. Using a newly invented mass spectrograph, he discovered that stable elements could exist in different atomic masses, providing the first evidence of isotopes. In 1895, Thomson implemented a policy change that allowed non-Cambridge graduates to conduct research at the Cavendish Laboratory. This decision attracted international talent, including Ernest Rutherford. Under Thomson's leadership, the laboratory earned a reputation as a, quote, Nobel Prize factory, nurturing numerous brilliant minds who would go on to win their own Nobel Prizes in physics and chemistry. Interestingly, J.J. Thomson proved the electron was a particle, while his son, George Paget Thomson, later proved it behaved as a wave. Together, they helped define the duality at the heart of quantum mechanics. J.J. Thomson died in 1940 and is buried in Westminster Abbey. His legacy lives on in every piece of modern electronics that relies on the electron he first discovered.